This is the basic concept behind all the wave optics stuff. I've got two waves in front of me. I've got a red one and a green one. And I can see there's a wavelength. It's about 4 squares long. And for each wave, it's got a crest to it, and it's got a trough. So here are all the crests for the red wave and all the troughs for the red wave. Now, there's this thing called the principle of superposition. And the principle of superposition says that if I have two waves and I add them up, their amplitudes will just add up in place in time. So for these two waves, when I add them up, I'm going to get this purple wave down below. So that's what the purple wave will look like. And the way it works is pretty simple. If I look at the crest of the first wave, that's the two red dots I put on there, I can see that the red wave at the top goes up 2 units, and the green wave on the top goes up 2 units. So at that moment in time where the red dot is, I know that the whole thing goes up 2 plus 2 units. Now at the blue dot, there's a trough and a trough. So I don't have any magnitude, so they don't add up to anything. Now with this animation, you can see how the wave shifted. Alright, so that shift is a phase shift in the wave. And when I add them up, I get the purple line down below. So because it shifted over half a wavelength, that's called a 180-degree phase shift, or pi phase shift. That's really important, because when I add up those two waves, I get that purple line down below. And if I look at it, if I look at this instant in time where the red dots are, with the red one, it goes up 1 block, and the blue goes down 1 block. So up 1 plus a -1, that gives me 0. And that's why it's the purple line. If I look at the next moment in time where the blue dots are, I get the same thing. I don't get any additional increase in amplitude, so it stays at 0. So when I add up waves that are half a wavelength, or pi, or 180 degrees out of phase, when it's half a wavelength out of phase, I don't get anything. If you were listening to this, I would miss sound. If you had one sound in phase, one sound half a wavelength out of phase, it would actually cancel it out. With light, if I had one color of light like out of a laser and I could somehow phase shift it, then I would get actually dark spots. I would physically be able to see the dark spots. So this is the basic concept behind all the wave optics, is looking at when the phases line up, then I see something or hear something, and when they don't line up, I don't see it and I don't hear it. So everything's based upon when you're half a wavelength off between two sources of waves.